Hi, I'm Dr. Ron W. Satz, founder and chair of the International Society of Unified Science. This is part 2 of my paper, Theory of Unit Space-Time and Displacements from Unit Space-Time, Material and Cosmic, Photons, Subatoms, and Atoms. If you haven't viewed part 1, I suggest you do that first. Okay, we're on page 19. Part D, Euclidean versus non-Euclidean space-time. In the reciprocal system, space-time is isotropic, homogeneous, and Euclidean. The curvature is 0. So kappa sub space-time equals 0. General relativity posits non-Euclidean space-time, and so the curvature is non-zero. Penrose, in reference 33, page 1023, says that in some versions, kappa spacetime is greater than 0, and in other versions, kappa spacetime is less than 0. Penrose himself seems to favor kappa spacetime less than 0, page 1005. But reference 56 gives us a fairly definitive observational result. The shape of the universe is the local and global geometry of the universe in terms of both curvature and topology, though strictly speaking it goes beyond both. Although the shape of the universe is still a matter of debate in physical cosmology, based on the recent Wilkinson microwave anisotropy probe, the acronym is WMAP, measurements, we now know that the universe is flat with only a 0.4% margin of error, according to NASA scientists. This refutes general relativity and supports the reciprocal system. Other tests of general relativity include the following, reference 47, page 149. 1. Light deflection in the gravitational field of the Sun. 2. Rotation of the apse line, that's the line connecting the aphelion with the perihelion of the inner planets such as Mercury. 3. Redshift of starlight. The reciprocal system can explain these situations just as well as general relativity. 1. Light deflection. A light ray passing a minimum distance r sub naught from the center of a star of mass m will be deflected by the angle, see reference 39, page 95. Beta equals 2 times 1 plus gamma times g times m divided by r naught times c squared in radians. In general relativity, gamma equals 1, whereas in Newton's theory of gravitation, gamma is 0. Morrison says, reference 8, page 36. The photon has no mass and therefore no gravitational motion toward a massive aggregate, a star for instance. But the gravitational motion of the star is distributed scalar motion, and this scalar motion of the star toward the photon, AB, is inherently nothing more than a decrease in the distance between the objects. It can equally well appear in the reference system as a motion of the photon toward the star, BA. On the basis of probability, the total motion is divided between the two alternatives. The total motion of the star toward the photon is distributed among so many mass units that the motion of each is unobservable. But the photon is a single unit, and it is deflected a small but measurable amount toward the star. End quote. Therefore, for the reciprocal system, gamma equals 1 in equation 11, so the factor of 2 times 1 plus gamma equals 4, which is twice what it would be for Newtonian gravity, simply because of how the reference system works. The deflection is not due to space-time curvature. Number 2, rotation of the apse line, for example, of Mercury. From reference 19, and based on equation 6 above, the orbital motion of a planet around a star of mass m is given by, and you can see the equation there, equation 12, where s is equal to 1 over r, that is 1 over the mean radial distance, and h equals the rate of change of phi with respect to time divided by s squared, and phi is angular displacement. But n sub s equals the right-hand side of equation 12. For any gravitational theory, the advance of the perihelion of the planet is given for small values by equals 1/2 times the rate of change of n of s with respect to s. As the planet advances through phi radians, its perihelion advances through p times phi radians. Now, equation 14 gives the expression for the rate of change of n with respect to s. For Mercury, we have these values. R equals 5.79091 times 10 to the 10th meters. As I've said, s is equal to 1 over r, and so s equals 1.726844 times 10 to the minus 11 per meter. d phi by dt is 8.266835 times 10 to the minus 7 radians per second. And then the value of h is 2.77223 times 10 to the 15th. So then we get that major factor, which you can see in equation 15. It's not much greater than 1. You can see that. Now, for a circular orbit, g times m equals v squared over s, and therefore dn by ds is going to be v squared over s times c squared times that factor from the previous page, 1.00000004 times s. And then we get p times phi, and for one revolution, phi equals 2 times pi. So p times 2 times pi is equal to v squared over c squared times that factor times pi, fraction of the revolution per revolution. Now, reference 45, page 294 gives the mean value of the velocity of Mercury as 47,872.5 meters per second. So, putting that in the expression, we get the fraction of the revolution per revolution, and then multiplying through by pi times 60 times 60 times 360, we get the arc seconds per revolution. Now, Mercury's sidereal period is 0.24084445 Julian years. That's from reference 45, page 94. Therefore, over a century, we finally get the result 43.107076 seconds of arc. Calculations with general relativity, see reference 40, page 579, gives 43.11 plus or minus 0.45. So we're very close on this, extremely close. From the standpoint of the reciprocal system, the advance of the perihelion of Mercury is not due to a gravitational effect, it is due to the relatively high velocity of the planet, and therefore due to coordinate time. Number 3, redshift of light coming from a large mass. According to general relativity, energy is, quote, spent by light to leave the gravitational field of the star or planet, so the frequency is reduced. But this effect is really due to coordinate time, like that of the advance of the perihelion of Mercury given above, except that we are not dealing with an orbit, so the orbital factor and pi do not apply here. This just leaves the half factor in v squared over c squared. Here, v must be the escape velocity from the star or planet. The equation then is frequency nu redshift equals 1 minus 1/2 times v escape squared divided by c squared times the original frequency. For the Sun, the escape velocity is 6.177 times 10 to the 5th meters per second, and hence the redshift frequency must be 1 minus 1/2 the escape Sun squared over c squared times the original frequency. And putting this into the redshift z, which is defined as new original minus new redshift over new original, we finally get that z sub g is equal to 2.122676 times 10 to the minus 6th. This is a very small effect. Reference 40, page 579 says the calculation from general relativity is 2.17 times 10 to the minus 6. The same reference says the gravitational redshift is not a definitive test of general relativity, however, for the Newtonian theory of gravity predicts the same redshift, assuming that the photon energy is h nu, and that the principle of equivalence and the law of conservation of energy hold. So the reciprocal system, general relativity, and even the Newtonian theory are tied for this effect, and so it is no, quote, proof for general relativity. Therefore, the proposition of the universe is Euclidean stands. But general relativity has other issues. It is in conflict with quantum mechanics, as Penrose points out over many pages in reference 33. It is difficult to see how a quantized space-time could be consistent with a non-zero curvature. It's also difficult to see how mass can affect space-time in any manner. The theory provides no mechanism. So it's difficult to see how space can be curved or warped or folded or any other crazy ideas of modern physics. E. Gravitational lensing. Astronomical objects like quasars often appear to be in two different locations at the same time. The conventional explanation of this phenomenon is, quote, gravitational lensing. The reciprocal system explanation, which is given in reference to page 301, is as follows, specifically in regards to quasars. Quote, and this comes directly from Larson, incidentally, inasmuch as the outward motion of a quasar has a specific direction, as seen in the spatial reference system, the lateral motion is confined to one specific perpendicular line. As noted earlier, however, scalar motion does not distinguish between the direction AB and the direction BA. The lateral recession outward from point X is therefore divided equally between a direction XA and the opposite direction XB by the operation of probability. Matter moving translationally at upper range speeds thus appears in the reference system in two locations, equidistant from the line of motion in the coincident dimension, the optical line of sight in most cases, and separated by 33.8 seconds of arc. Please see reference 2 for more details. F, uniform rate or non-uniform rate of space-time. In the reciprocal system, space-time flows at a strictly constant rate, c. A contemporary theory called, quote, inflation, says that shortly after the Big Bang, or I should say alleged Big Bang, there was a period of time in which space-time flowed faster than the speed of light. This is necessary in conventional theory because the universe is reportedly 93 billion light years in diameter, according to reference 57. But there was actually no Big Bang, and so the universe could be vastly older than currently estimated. G, unit space-time and displacements from unit space-time, vacuum properties. Space-time cannot be physically changed in any manner. The existing physical displacements from unit space-time, such as photons, subatoms, and atoms, therefore have the character of, quote, postulates. If there were a creation of the universe, both unit space-time and the displacements from unit space-time are created together. The displacements cannot revert back to bare space-time. Displacements are conserved. There are no virtual particles in the reciprocal system. The acceleration due to the space-time progression outside unit space at an opposition to gravitation is 1.144 times 10 to the minus 13 newtons per kilogram, reference 17. In contrast, quantum mechanics supposes that the, quote, vacuum is a very busy place, with all manner of virtual particles popping in and popping out of space-time. But these are unobservable, according to reference 42, page 1239. On page 1240 of this same reference, the authors boldly proclaim that the energy of the, quote, vacuum is, believe it or not, 10 to the 111th power joules per meter cubed. Obviously, this is utter nonsense. H, principle of equivalence. Here the reciprocal system and general relativity agree. Gravitational mass and inertial mass are perfectly equal. The reason for this in the reciprocal system will be explained later in this paper, but it's obvious that gravitation is accelerated motion. I, special relativity and paradoxes. As is well known, special relativity has the clock paradox and the twin paradox, which can be resolved only by utilization of a fixed reference system. See reference 1, second edition, pages 85 to 88. Therefore, motion cannot be purely relative. It is ultimately absolute. See the discussion below on the cosmic microwave background radiation. We'll get to that in a moment. J, general relativity and coordinates. Larson states very clearly in reference 5, page 94. Here we have the essence of general relativity. Special relativity accomplished its objective of providing a mathematical correction for the conceptual error in the conventional view of time by abandoning the idea that the magnitudes of time and space intervals measured with respect to coordinate systems of reference have fixed values, and introducing a fictitious variability in these magnitudes. To meet the additional problem of accelerated motion, Einstein simply prescribed a bigger dose of the same medicine. It took him 7 years to figure out where the additional flexibility could be introduced, but finally he created more latitude for numerical variation by depriving the coordinates themselves of any meaning, so far as mensuration is concerned. Of course, in the reciprocal system, coordinates have meaning. Okay, simultaneity. Larson explains the reality of simultaneity in the reciprocal system, reference 5, pages 111 to 112. Quote, in earlier days when physical science dealt only with relatively low velocities, the contribution of the coordinate time to the total time interval in any physical process was negligible, and it was possible to carry out all calculations involving motion on the basis of clock time only. The advent of high-velocity measurements, particularly those concerned with the velocity of light, showed that there was an error somewhere in the system, and there was a study of the background of this discrepancy that led Einstein to his conclusion that, quote, there is no such thing as simultaneity of distant events. If we are referring to total time, this present study is in full accord with Einstein's conclusion, but for most purposes, the useful definition of simultaneity is that which regards events as simultaneous if they occur at the same clock time, that is, at the same stage of the time progression, and this kind of simultaneity definitely does exist. Continuing with this quote from Larson, Einstein and his colleagues accepted the, quote, operational point of view in this instance and rejected the concept of an objectively real simultaneity because of its lack of an operational basis. As Moeller explains, the concept of simultaneity between the two events in different places obviously has no exact objective meaning at all, since we cannot give any experimental method by which this simultaneity could be ascertained. The present work shows that this conclusion is an error, that simultaneity defined as the same clock time is something that can be ascertained by physical means, and this concept can therefore be legitimately employed in any connection in which it happens to be useful, a category that includes most of the applications in which the idea of simultaneity is normally employed. In this sense, the only sense that is of any particular importance to us, Einstein is wrong, and there is such a thing as simultaneity of distant events. L. Summary. The conventional theorists need the Big Bang, inflation, dark energy, and general relativity to explain the observations, whereas a reciprocal system just needs the space-time progression and Newtonian gravitation, modified by coordinate time, to explain the observations, including the acceleration of the universe. See the appendix in reference 17 for the numerical calculation of this acceleration, which increases with time. Now, moving on to section 2, photons and radiation. A space-time nature of photons and radiation, Maxwell relations. The space-time progression is uniform translational motion. The first kind of displacement from this is linear vibration motion. This linear vibration knocks out the space-time progression in the dimension of the vibration, leaving two dimensions available, one of which is used. This dimension is perpendicular to the progression. Therefore, this object is a linear vibration moving at the speed of light in a perpendicular direction, resulting in a sine curve. Quite obviously, we can identify this combined motion as radiation, and we can identify the linear vibration as a photon. Unit frequency may be identified as the Rydberg frequency for hydrogen isotope 1, R equals 3.28806 times 10 to the 15th hertz. Displacements above R are considered to be, quote, high frequency, whereas displacements below R are considered low frequency. The first displacement above R is 2R, whereas the first displacement below R is 1/2 R. There's nothing electromagnetic about radiation. Maxwell reference 55 incorrectly deduced his theory of radiation as electromagnetic by his famous relation, C equals 1 divided by the square root of epsilon naught times mu naught, where epsilon naught is the electric permittivity of space-time, free space-time, and mu zero, or mu naught, is the magnetic permeability of space-time. Of course, in the natural units of the reciprocal system, these parameters have the value of exactly 1. That's the C. The dimensions of epsilon naught are s squared over t, and those of mu naught are t cubed over s to the fourth, see reference 11. And so the dimensions of C are s over t, of course. There's nothing electric or magnetic about space-time, and so there's nothing electrical or magnetic about radiation. The textbooks are all wrong. Table 1 gives the spectrum of photon frequencies. And you can see radio waves, microwaves, infrared rays, visible light, ultraviolet rays, X-rays, gamma rays. I have columns for energy and electron volts, frequency in hertz, wavelength, variable units, some millimeters, some kilometers, natural frequency based on R, and the inverse name. That's table 1. Okay, section B, Planck's quantum of radiation energy and calculation of Planck's constant. The reciprocal system accepts, of course, Planck's concept of the quantum of radiation energy, the photon, and Planck's and Wien's radiation laws. The energy of a photon is a linear function of its frequency, the perpendicular translation of space-time, which reads nothing to the energy, E equals h times nu. None of the conventional references give a derivation of the value of Planck's constant h, but we can derive this constant by means of the reciprocal system. For convenience, CGS units will be used here. 1. Observers in our sector, the material or time-space sector, measure photon frequency in cycles per unit time, such as cycles per second. In this sector, time appears to be one-dimensional and progressing. 2. Observers corresponding to us in the cosmic or space-time sector measure photon frequency in cycles per space unit, such as cycles per centimeter. In this inverse sector, space appears to be one-dimensional and progressing. 3. From statements 1 and 2, it follows that to have a definition covering both sectors, we must combine the two equations and measure photon frequency in cycles per space-time unit, such as cycles per centimeter second. In application to the time-space sector, the numerical value of the space factor in the general equation is set to unity. In application to the space-time sector, the numerical value of the time factor in the general equation is set to unity. But it's important to realize that the dimensions of these factors are still present. In our sector with energy and ergs, the dimensions of the energy equation are erg equals second squared divided by second per centimeter divided by erg times 1 over centimeter second. In the inverse sector with energy in grays, inverse of ergs, the dimensions of the energy equation are gray equals centimeter squared divided by centimeter per second per gray times 1 over centimeter second. From these two expressions, it follows that Planck's constant in our sector has the dimensions of erg centimeter second, and Planck's constant in the inverse sector has the dimensions gray centimeter per second. With the space factor unity in our sector and treating the frequency here as cycles per second, the units of Planck's constant become erg seconds. With the time factor unity in the inverse sector and treating the frequency there as cycles per centimeter, the units of Planck's constant become gray centimeter. 5. The ratios second per centimeter to erg and centimeter second per gray in the equations above are simply conversion factors from the natural system to the CGS system and SGC system, the equivalent of the CGS system in the inverse sector. The ratio of second per centimeter per erg is 2.236055 times 10 to the minus 8. And that's from reference 1, second edition, page 161. 6. The factor for second squared in the expression for our sector comes from the natural unit of time expressed in seconds squared. Similarly, the factor for centimeters squared in the expression for the inverse sector comes from the natural unit of space expressed in centimeters squared. These terms are the keys to transforming the frequency to energy and must be included. 7. Finally, the interregional ratio between the time region and the time-space region, between the space region and the space-time region in the cosmic sector, must be included because the oscillation of the photon takes place within a unit of space-time. So, the result for h in our sector is t sub u squared divided by I sub r, which is the interregional ratio, times 2.236055 times 10 to the minus 8. And that gives us h equals 6.610263 times 10 to the minus 27 erg seconds, with frequency given as cycles per second, or as 6.610263 times 10 to the minus 27 erg centimeter seconds, with frequency given as cycles per centimeter second. The resulting quantity of energy in ergs is identical in both cases, and of course there are similar values for the cosmic sector. Accepted value is 6.626 times 10 to the minus 27 erg seconds, and this value has been used in most papers and books on the reciprocal system, pending clarification of this small discrepancy. The ratio of the calculated to accepted value is 0.9976, or approximately 99.8%. The respected experimentalist physicist R. Millikan found H to be 6.57 times 10 to the minus 27 erg seconds, reference 54, somewhat lower than the accepted value today. See, calculation of the Stefan-Boltzmann constant. The reciprocal system accepts the Stefan-Boltzmann law and the thermodynamic calculation of the Stefan-Boltzmann law. You can see the references there. The Stefan-Boltzmann law of radiation energy from a black body radiator is expressed as equals sigma times 2 to the 4th power, where sigma is the constant. 1 unit of radiation leaves per unit of area per unit of time. Unit of thermal vibration expressed in CGS units is u sub 1 equals 1 cycles per centimeter second, for reasons given in section B above. Unit area is the square of the natural unit of space, that's sub u in CGS, reduced by the interregional ratio of I sub r. Thermal motion in the time region is effectively only half the time because the space-time progression acts inward here. Therefore, observing dimensional consistency, we obtain this value for sigma, and you can see the expression there for sigma. So we calculate 5.882079 times 10 to the minus 5th ergs per centimeter squared per second per Kelvin to the 4th power. Accepted value is 5.670400 times 10 to the minus 5th, from reference 50, page 1, and 1, 2.7% lower than that calculated. Possibly, any so-called black body may really have a touch of gray, thus the measured value may slightly underestimate the true value. The dividing line between atomic translational motion in space and motion in time. Although unit radiation frequency is R, this value is not necessarily the frequency which divides the emission absorption of photons due to translational motion in space, material sector, and time, cosmic sector. Over all cubes of coordinate space and coordinate time, the numbers of and types of photons from matter and photons from cosmic matter must equal. The standard references give a range of values for the energy of radiation per cubic centimeter. For our purposes here, we can assume roughly 0.5 electron volts per cubic centimeter from matter starlight and 0.5 electron volts per cubic centimeter from cosmic matter starlight, that is, the cosmic microwave background radiation. Incidentally, the energy from cosmic rays is estimated to be 1 electron volt per cubic centimeter, so we can assume that the energy from matter rays to the cosmic sector is also 1 electron volt per cubic centimeter. So the universe is in balance. Because the cosmic sector is localized in coordinate time rather than coordinate space, we cannot see cosmic stars and galaxies. But the photons from either sector are perceivable, though reduced by the proper distribution factor between the two sectors. Arson says, reference 3, page 202, that this distribution factor is 128, meaning that R is reduced by 128, giving a wavelength of 11.67 microns. So therefore, we get that the dividing line is 2.568797 times 10 to the 13th hertz, or in wavelength, it's 1.167054 times 10 to the minus 50 meters. Reference 3, page 204. Our findings show that what is needed is a recognition of the existence of the unit boundary at 11.67 microns. Strong radiation in the far infrared beyond 11.67 microns comes from matter with speeds in the upper ranges, above the speed of light. not from the relatively cool thermal sources like those that radiate weakly in the far infrared. As we will see in the pages that follow, strong infrared emission is one of the conspicuous features of the objects that we will be identified as involving motion at upper range speeds. Quasars, C4 galaxies, the cores of other large galaxies, exploding galaxies such as M82, etc. The infrared radiation from the quasars is estimated to be 1,000 times radiation in the visible range. The association between infrared emission and radiation in the radio range, which we identify with upper range speeds, is another feature of these objects, which, like the infrared emission, is unexplained in current astronomical theory. The significance of the results of the surveys of the infrared sources within the galaxy, such as the one reported by Neubauer and Beckman, is that they demonstrate the existence of the line of demarcation between the far infrared of the infrared speeds and the near infrared of the speeds below unity. Table 1 shows the names for the inverse values cosmic observers would see as shift to shorter wavelengths, higher frequencies, or R dividing line times 128. Okay, that concludes part 2 of the paper, and you may now proceed to part 3.